Awesome. I think for the sake of time here, we have a lot of things to cover, so I want to go ahead and get started. My name is John Taubensee. I'm a program manager on the Azure messaging team, and I'll talk a little bit about what services that's actually comprised of here shortly. I also wanted to let everybody know that this is a repeat session of the session that Dan Rosanova gave yesterday. So there's no additional new information, but there's still a lot to cover regardless. So with that, we'll go ahead and get started. So some of the things I wanted to cover today, just to give a very brief intro to our services, what they are, talk about the updates to each service, talk about the future updates that we expect to do, and then for any Q&A, any moments I have during the presentation, feel free to ask. Otherwise, I'm available after the session. So Azure messaging services, there's three services that comprise Azure messaging. The first we refer to as messaging. You guys may know it as Service Bus. This is a product that's very similar to other messaging services out there, like IBM services, MSMQ. It's a publish subscribe enterprise messaging system, but there's also a lot of advanced features that come with it, like sessions, transactions, deduplication. The primary selling point to this service and all the other services I'm about to talk about is that it's PaaS, so it's platform as a service. There's no hardware or licenses that you guys have to deal with on your own. It's all included in it's a pay-as-you-go service. The next is Event Hubs. Event Hubs is a distributed telemetry and logging service. There's a lot of similarities between it and messaging. Some of the key differentiators between that, though, is that it is it is a system where messages will stay on the Event Hub until they roll off. So as soon as you receive a message, that message is still there. So in order to read messages, there's a client-side cursor, and there's services that integrate with this directly. There's also a library that we have called Event Hub Processor, and that will help you process those things. It makes it pretty easy. The last service that we have is called Relay. Relay is a service that helps you in hybrid solutions. It allows you to project a public endpoint for a private on-premise resource, and we'll go into a couple details about that later. So with all of those services, here's kind of what some of our usage looks like. In the last week alone, Event Hub's had 3.8 trillion requests. And across all the services, we're running at about 6.3 million requests per second, 24/7. So while these numbers alone are impressive, what I am really proud about is the success rate. So 99.99% success, and then we also have a 50 millisecond send time to Event Hubs. So with all those numbers being so high, who's using messaging? This slide here really kind of shows that people across all industries are using these messaging services. It's not so much about which particular industry you're in nowadays, it's more about the cloud architecture and developing distributed systems. So you'll see things in here like insurance, logistics, government, healthcare, power and utilities. That one I want to draw particular attention to because Kent Weir and myself will be giving a presentation this Friday at 12:30 to talk a little bit about some of the use cases that his company uses in particular. So it'll give you a good real-world scenario of how these things work. So the first update that affects all of our services we're referring to as namespace split. How many of you guys use Service Bus and Event Hubs today? Do you guys use them together, or are you more kind of Event Hubs or Service Bus, one or the other? Okay, primarily Service Bus. So this probably won't apply to you guys, but for those of you who use both of our services, we are splitting the namespace. And this is primarily because Service Bus is where a lot of these services originated from. So Event Hubs came from Service Bus, Relay came from Service Bus. So they all had shared namespaces in the past. So you could have a namespace that could have messaging entities being queues and topics, Event Hubs, or Relays all on that same endpoint. Moving forward, we want to split that. We want to do that because we want to be able to scale these services independently. We want to be able to release these services independently, and we want to reduce the dependencies between them. So as far as an impact, there will be no runtime impact. It's all about management. So moving forward, you will have to update ARM templates if you guys use that. You will also see, like for instance, you won't see your event hubs in the new Azure portal if you have messaging entities on that namespace as well. So I'm sure there's probably some questions about this. I'm happy to stick around after and answer those. This is also available as a blog post that will give you a little bit more details around that. So just to give kind of a messaging overview, we offer messaging as a service essentially. This is comprised of queues and topics. And the key piece here is asynchronous communication. And the reason for that is to remove or to add temporal decoupling so that there's not strict runtime dependencies between systems, and also to insulate those systems from one another. So if one system is down, it doesn't take the other system down with it. That's the goal. With that, we have features like routing and filtering, and we also have convoys and sessions. And as an example, sessions are messages with related state. These are some of our differentiating features. For instance, if you had messages that needed to be in a particular order, or if you had, if you want to do request-response style messaging between senders and receivers, you could do that with sessions. You guys probably know basically how a queue works, but just as a quick overview, message sends a message, or a sender sends a message to a queue. The queue acknowledges receipt of that message. At a later point in time, the asynchronous piece here, the receiver can connect to that queue, receive that message, and then they later send an acknowledgement to it to say that that was completed, or they can abandon that message and say that processing failed. We also have topics and subscriptions under the messaging umbrella. This is a little bit different because the sender only knows about a topic and receivers only know about subscriptions. But with that, you have filters and actions. So essentially here, I can say, for a message of type order, I send a subscription 1. For a message of type quote, I send a subscription 2. So therefore, receivers only connect to the subscriptions that they care about. So some of the new things for messaging, we're now available in the new Azure portal. We are no longer the last service to not be there. We're also available in Azure Resource Management, some of those ARM templates that I was talking about. You guys probably have started using ARM templates. These are great for quick, reliable, repeatable deployments. So we're happy to be there. We also have Swagger templates out for our resource providers. So this is essentially a REST template that you can use to easier develop your own REST integrations, but this also allows us to provide you guys with a management library that will allow you to do things like create namespaces, other entities like queues and topics as well. We also just recently went GA with our premium service. The main point about premium is predictability. So the performance that I get today will be the performance that I get tomorrow. And so with that predictable performance comes predictable price as well. So you are essentially paying for predefined set of hardware essentially, or reserved instances. And so with that, you aren't charged for the message anymore. You're only charged for the compute and memory that you're using. And that's not a variable price, it's a set price. So with that, we're able to provide larger messages. Messages are no longer a max size of 256 kilobytes, they're now a max of 1 megabyte. This obviously allows you to get to higher scale. And with this, another point that we wanted to make is that since this is dedicated hardware for you guys, we're able to innovate quicker and add more advanced features on this hardware. Since it's not a shared tenant model anymore like standard and basic, there's no risk of there being noisy neighbors situations. And things such as larger messages easily create those. So here's a quick slide just to show you what kind of performance you can actually expect. So you'll see that this is all kind of based upon the number of MUs. It scales for the most part linearly. With 4 MUs and a single send receive to a queue, we are able to both send and receive almost 17,000 messages per second. This is, we thought, a pretty good use case. One thing to keep in mind is that we do a couple of messaging best practices here. We do batching. Our message size is only 1 kilobyte. If we went up to a meg, you would see that number go down. Vice versa, if we also went down in message size, you'd see that number go up for performance. And there's also a blog post about this, and this is an open source client that we published to kind of help promote those best practices as well. The next service I want to talk about is Event Hubs. Here's just kind of a basic diagram of what most customers' Event Hub solutions look like. The key feature here, or the key point that I want to make here, is that you have applications, IoT, other devices, Windows servers, all cloud gateways such as Web API or API management, all these different devices posting data to Event Hubs. So Event Hubs is essentially acting as the gateway here. The second half of this diagram kind of shows what people do with that data once it's up in Event Hubs. With the integrations with Stream Analytics and Azure Functions, you'll now see people are able to utilize that data and do awesome things with it. So essentially they can go from Stream Analytics, do real-time insights, post things to Service Bus, post things off to other databases as well. So this is kind of just what it looks like today. As far as the conceptual architecture of how Event Hubs actually works, you have an Event Hub with partitions inside of it. You can send and receive to particular partitions. You've got senders, you've got receivers on the other end, and you'll also notice that there's consumer groups. Consumer groups is an interesting topic because it allows you to both process your data in multiple streams. So essentially you can have a real-time stream and you can have a batch stream. So remember I said earlier that Event Hubs will keep a message until it's actually rolled off after 1 up to 7 days. So that's why this is here. So these consumer groups and their receivers have their own client-side cursor that keeps track of where they are. So some of the updates that are coming with Event Hubs, we now have a new portal, and you'll notice that when you log into that portal, there's some new metrics. There's a couple things there that will help you guys better judge the health of your system. We now also have a native client built on top of ProtonJ. In the past, we didn't have a very good Java story. We essentially just said, go use ProtonJ. That wasn't as easy as we wanted it to be, so we built our own library and we abstracted that away. That's a library that's fully supported by us. With that, we also have a new core CLR client. One thing that's interesting to note, both of those clients are open source and available on GitHub at that link, but the core CLR client is based upon .NET Standard. So this is a library that can be consumed by the full .NET framework or by .NET Core. So with that in mind, this will become our eventual primary client library. And so you'll see that this can be complemented with some of the other management libraries that I was talking about with that Swagger spec that's also available for Event Hubs. We also see that Event Hubs is becoming connected to more Azure services that are out there. Now there's also an IaaS VM agent where you can set Event Hubs as the endpoint, and with that it would send all your logging to Event Hubs. Azure Functions now has an integration. You can trigger a function based upon an event that comes in. There's also API management as well, which would use Event Hubs as a logging destination, and Apache NiFi also has an Event Hubs integration. The last two things here that I want to quickly mention is dedicated capacity and Event Hubs archive. So dedicated capacity is a service that we're offering for single tenant customers who really need the highest scale. So for people who want to do things like 1 million messages a second, we will offer you a dedicated cluster for Event Hubs. This has fixed monthly pricing, it's sold in capacity units. It does require a purchase commitment, and it's available in any region that Event Hubs is currently available in. Event Hubs Archive is a feature that just recently went into preview. It allows you to automatically send your events to blob storage. Previously, you had to use things like Stream Analytics or the event processor host to write things out to blob storage. Nowadays, this is a point-and-click solution, and you can add it to existing Event Hubs. So there's no code to run. It's all can be configured through the portal or through ARM templates, and you can send an event to Event Hubs and expect it to show up in blob storage. So this allows you to quickly enable batch processing, and this for using services that you already use, whether it's Azure Data Factory or Hadoop to process blobs. And this is something that you can try today. So with that, Event Hub's archive is now the easiest way to get data into Azure. And with that, with all the connectors that we're talking about, you can use things like Stream Analytics, Data Factory, HD Insight to process that data. So the last service that I want to talk about is Relay. Relay is an interesting service. It's essentially a real-time communication proxy, and it is used in really only hybrid solutions. And so it's used to essentially decouple location, security, VPN, and firewall. So essentially you don't need a VPN or complex firewall configurations in order to take an on-premise asset and expose it to the cloud. Let's see, so here's kind of how that looks. So you don't have to do that, but the service would register a cloud endpoint. A client would connect to a cloud endpoint. These are both outbound connections. And then, as we like to say, network magic happens. But the key there is that these are both outbound connections. It's not an inbound connection going back to your on-premise service, so it allows you to access those things. But Relay is a service that's been around for quite some time, almost 7 years. And so with that, there's a couple of limitations. It hasn't quite gotten the love that it's needed lately. It's a service that runs really in only WCF nowadays. So moving forward, we want to provide a Relay that is available in the new portal, available on any platform, also uses widely implemented standards such as WebSockets, doesn't require WCF, and this is something that the team is working on today and something that we hope to be out soon. So with that, I know that was a very brief overview of all these things, but messaging has never really been more relevant than it is today. It's not about the industry you're in, it's about the cloud systems that you're trying to connect. So with that, if you have any feedback, please let us know. I think I have a minute or two here for questions if you guys have them. Otherwise, I'm happy to take these things offline. So thank you.